All right, I have added a bit of reading about colors today in processing. That's the goal today, is to talk a little bit about colors. And then hopefully if we get through that, at the end I can talk about really, we've been drawing these static figures. We drew static figures on Monday. Really, processing is about drawing animated figures, and so we're going to hopefully get into a little bit of that, Rebecca.
So, in the homework, you say draw a picture.
Yes.
Is a circle a picture? Like how are we going on that?
Okay, I'll make it totally subjective, and I'll give you a score from 0 to 1 on how much I like the picture. How's that? Okay.
What's your favorite shape?
Really? You think I'm a trapezoid kind of guy? I mean, I'm somewhat offended now.
I'm going for
Here's my favorite shape right here.
We can do that.
Okay, we might actually do this for the last assignment. We'll see. See how far we get. Yeah, draw me a picture. More than a circle. Yeah, make it interesting. And then hopefully we'll get through the animated stuff today and Friday, and you'll be able to play around a little bit with that as well. Emily, question?
In terms of parallels to the self-text exercises from the book, is that more just reading the tutorials, doing them?
Yeah, pretty much. Yeah, I mean it's we're out of textbook land.
Yeah.
But definitely, the coordinate system is going to be something that I'll ask you about on an exam. How colors work is something I'll ask you on an exam, stuff like that. My hope is that it's all stuff that you'll just pick up by osmosis as you're programming. Okay. Some of you, all of you, were having trouble downloading processing. Let's just go briefly there and see what that process looks like. No pun intended. So this machine is a Windows 64-bit computer. So if I click on that, it'll start downloading, and it'll take a while. And then once this thing is done, it's a zip file. You just double-click on the zip file and blow it up wherever you want, and processing is inside, and you run it. It should be as simple as that. So it doesn't really have an installer sort of the way maybe some more formal programs have. It just sort of unpacks itself into a folder, and then inside is the processing app, and you double click on it and you run it. And as you can see, it's quite large, so I'm not going to download it again. So I think based on the file name that it was giving that there's already a copy in there. So let's go into downloads. Yes, right there. Maybe. So if you click on that guy, you get something along the lines of this, and somewhere there'll be a button that says extract, and you click extract and keep clicking extract until it extracts, and this too will take a while, and then inside you'll have yes, I'm going to cancel this too. Windows is so slow. Alright. And then if you want to put the link on your desktop or something, that's fine. Otherwise, just go digging around in the folder. Have Mac people successfully done this? And it was sort of not too difficult? Jason? Yeah. Okay. All right. If, of course, you're having trouble getting this thing up and running on your computer, ask me after class, and we'll make sure that you get straightened out. Processing's a little fussy about where it keeps its files and folders. The default location is fine for most people, but it likes to keep everything inside the sketchbook folder. You can set the location of the sketchbook folder under the Preferences dialog here. So you go to File, Preferences, and then you can browse for a sketchbook location. And then everything thereafter will be in folders inside this location. What I'd like to start talking about today is how color works on, in fact, in most graphical programming, processing included, color is represented by its three components: red, green, and blue. And what you do is you get colors by mixing those fundamental or primary colors in correct proportion. So, without further ado, let me get a canvas here. Let's make it 500 by 500, and I'll set the fill color. Instead of a single number, if I give it 3 numbers, then the fill function is smart enough to know, hey, I'm getting 3 numbers. So now I'm not doing grayscale, I'm doing colors. And the 3 numbers in order are always R, red, G, green, B, blue, RGB. And the values range between 0 and 255. So R, comma, G, comma, B, and values from 0, which is black or nothing, to 255, full, as much color as you can get in there, and then all the values in between. So I can use the fill command to set the color at a particular moment. In fact, I think I already have. I'm gonna go and look at an example that I think I already cooked up. Let's go here, here, here. Yes. Okay. How do I want to open that? Well, I guess I'll just drag it and drop it onto this thing. Yep, and it's behind the scenes there. Can everybody read this okay? The text is large enough? Yeah, okay. Let me know if it is and I can crank it up. So here I have 3 ellipses. They're actually circles, and if I press play, I see them here, and we see an illustration of how the order in which you draw these things matters. So the first one that was drawn is this guy, the second one is this guy, and the third one is this guy. And the order matters. So the most recent one sits on top of all those previous ones. I can change the color of each of these guys. For example, the bottom one I can set to, say, red. So what does that mean? 255 is turn on red as full as it'll go, and turn off green and turn off blue. And what we see is everything afterwards is filled with red. Well, what if I'd like red and then blue? I just change the fill color after I draw that particular element. Sorry, green. And then let's do blue down here. So that's red. That's green. And that's blue. And each ellipse just uses the fill color of the most recent fill command. And you can call fill as much as you want. You can put fill inside of a loop. You can do all kinds of crazy stuff. You might wonder about, I mentioned R, G, and B as being primary colors. The word primary colors, you run into an art class and it's not usually red, green, and blue. and frankly, I don't know the history of why we use R, G, and B in programming, and we use, what are the primary colors in art, like red, blue, and yellow? Yeah, so it's not clear to me why there's that distinction. I suspect it has something to do with the ease with which displays can render colors, and it might be that there's something easier about working with RGB and hardware than whatever the other one was, red, blue, and yellow. Yeah. So, but I don't know the history of that. Another thing to note here is that the color model that most computers use is something called an additive color model. That means it's sort of like, one of the biggest discoveries that Newton made was that white light was in fact not pure light, as people up to that point had thought, but in fact white light was actually the superposition of all frequencies of light, or most of the visible frequencies of light. And so if you add these guys together, what your eye perceives is white light. That's the same model that we use in computing. The colors add. So if we were able to see the overlap of these three guys with full red, full blue, full green, what we would have is white in this model. In fact, we can do that. We can just turn on down here all three channels. Full red, full green, and full blue. And if I run that, the last guy is white. That's additive. Now if you take red, green, and blue paint and you mix it together, what do you get? Crud. Right? You get crud. That's because paints use a subtractive color model. And I won't get into that, but there is a basic fundamental difference between the color models used in computers and those that, say, an artist would use with oil paints or something. Okay, now, there is a fourth value in the color scheme that you can use. And I'll throw it in there on the last one. I'll put a fourth value, 128, and run it. And that controls transparency or opacity. The fourth argument and 0 is fully transparent. I need to and 255 is fully opaque. So if I throw in this third argument and I change it to 0, what do you think will happen? I'll see the outline of the circle, but not the interior of the circle. So let me stop this and run it. So that's actually filled with blue, but it's 100% transparent, so you don't see it. On the plus side, you get to see the stuff underneath it, which is maybe something that you would want to do. If you crank it all the way up to 255, then you're back to the original figure that I threw up there, and you can't see through it at all. Let's try. So what do you think 128 is doing? That's about half. So it's about half transparent. And we could do that for all of these guys. We could put half transparent here and half transparent here. And you get kind of an expected result. You don't get white in the middle. Why not? You do get gray in the middle. but not white.
Is it an opaque?
Kind of,
The
yeah.
blue is a different blue than the fully opaque blue.
Right. So it's not full-on bright blue, right?
Yeah.
Because it's sort of washed out by the background. What if we change the background to white? We could try that. No change? Well, little change maybe. Yeah, you're not going to be able to get white from 3 overlapping transparent objects because the transparency necessarily kind of drains it of its power. So there's transparency and there's additive colors and there's this mix of the two ideas. What we're talking about here is saturation, how much of a particular channel is in there. For example, what do you think would happen if I changed the blue circle to something like, oops, not that guy. What do you think would happen if I changed the blue circle to something like 50, 50, 50, 128? So if you have each of the 3 colors in equal proportions, but not full, think about the extremes. If it was full, if it was 255, 255, 255, you'd have white. If it was 0, 0, 0, you'd have black. It's going to be some level of gray. And there it is. Okay, any questions about color? Not only can you do it with fill, but you can do it with stroke. So I could do something like stroke 255, 255, 0, say. And what this will do is paint the boundaries yellow. Okay, so that's full on yellow.
Is there a way to make all the shapes occur the same plane if there's no same thing?
Not sure what you mean.
So right now there's the natural behavior of the program is to set each point up in the last.
Yes.
Is there a way to override that so they're all so they just overlap?
What would it look like?
Well, it would be over. Well, we wanted to get the actual overlapping circles with whiteness and everything.
Oh, I understand. You'd have to work harder at that. It's not as hard as you might think, though. But you'd have to get down and start playing around with the pixels and seeing which pixels lie in which circle and doing it that way. So I think the short answer is there's not an easy way, but it's not terrible either. Other questions? You could crank up the thickness on this thing too, if you really like. I think it's stroke width. It's not highlighting though. Okay, here's another lesson for you guys. The processing web page has a lot of information, and you can always go to the reference section and just search for a particular function. I think it's called stroke weight. That's it, stroke weight. So you go there, you can click on this thing, and you can get a description of what this particular function does and how it's used. What's funny? Oh, beastly, yes. So we can go here and change this to stroke weight. And you can think of this number as really just how wide is it in pixels? How wide is the stroke in pixels? So we crank up the stroke weight to 3. So instead of 1 pixel wide, it's 3 pixels wide, and we press play, and we get a much more vivid boundary than we had before. Questions? All right. So I would encourage you to bookmark this thing, go here, read about anything that you're stuck on. It's all here, and it's all relatively well written. So I'm going to break here and let Ami do his thing. So why don't you come on up, Ami, and we'll get your... I forget what your topic was.
The driverless car.
Oh yeah, that's right. So go ahead and pull that out.
The USB. I just minimize this.
Sure. Should pop up hopefully. It's really
Not used to the.
Yeah, the Windows 8 thing is here.
I'll just let you.
No problem. Come on, removable disk, you can do it.
I also have it on my email too.
Let's have a race. Did it work? No. Oh, use the other one. I think it's that one. No, it's that one. Did it run?
I think it downloaded.
Alright, email wins. And you want sound, right?
Yeah.
I can't see which one is which. I think it's this one. Go ahead.
Alright. So my topic is what is the current state of the self-driving car, and I'll just show you this quick video from Google.
Good morning, Steve. Hey, Nathaniel, how are you? Doing just great. Go ahead, Steve.
Auto driving.
Here we go. Away we go. Look, Ma, no hands. No hands anywhere. No hands, no feet. No hands, no feet. No nothing. I love it. So we're here at the stop sign. Yep. Car's using radars and laser to check and make sure there's nothing coming either way. I find myself looking. Old habits die hard, man. They don't die. Hey, anybody up for a taco? Yeah. What do you want to do today, Steve? I'm all for tacos all myself. All right. Well, let's go get a taco at the drive-thru. And we're turning into the parking lot. How neat. There we go. Now we kind of creep along here. Does anybody have any money? I've got money. No, I've got my wallet right here. You roll down your window and order a burrito. Yeah, push that. I'm doing very well. How are you today? This is some of the best driving I've ever done.
Cool. So I think you get the point.
It's a blind guy, yeah.
Yeah, he's partially blind. He's got like 20% of his vision. Yeah. And so that's Google's car. And that was in Mountain View, and that was posted about a year ago. So they've been working on this for a couple of years. Other companies have been working on cars following Google. All the big companies like Toyota and Acura, all the big brands. So you might be asking yourself, why do we need self-driving cars? And there's many reasons. For example, productivity. Instead of like driving, the half an hour to work and back, you could be reading your emails or reading the newspaper. In terms of traffic, if all the cars on the highway, particularly in California, where you might be spending an hour a day on the highway, if there's all driverless cars, they could all be packed much closer together on the freeway, and you could also some cars could take alternate routes, and then instead of everyone taking one route, you could like split it up and have the computer like allow these people to go on this route and half the people go on that route, so you're not like congesting one route. As well as hypothetically, you could have faster speed limits if the cars were like not going to make a mistake like people do. Fuel efficiency, since the computers can tell like, oh, in like a mile there's going to be a stoplight, you might not like hit the gas because you're going to have to come to a stop fairly soon, and the computers can do that more efficiently than people can. They can also pick the most efficient route and shortcuts as well. And the biggest thing is to reduce human error, and computers can do that. And because we can. So let me just go over some of the things about how it works. So autonomous vehicles sense their surrounding with such technology as LiDAR, which is the rotating sensor on the roof that scans more than 200 feet in all directions, and it generates a 3D map. It also has video cameras and radar to assist in determining the distance of objects, traffic signals, and pedestrians. It has GPS and a position estimator, which is the thing right here that's located on the rear wheel, and that helps locate the car's position. Most cars are able to update their own maps using sensory inputs, which allows them to drive in uncharted environments. And the system also provides for an override that allows the human driver to take control of the car by stepping on the brake or turning the wheel, sort of like cruise control in most modern cars, to disengage the automatic feature. And here is what the LiDAR looks like. This is a 3D map that it generates, and it like spins around on the top of the car and creates like this map. And this is what the LiDAR looks on the top of the car, and it's got these laser emitters and receivers, as well as the motor that allows it to spin. So Google's driverless car has completed about 300,000 miles on the roads accident-free. However, the biggest issue is that the technology is ahead of the law in many ways, and most state laws presume that the cars have a human being operating the vehicle. So that's sort of the biggest issue. In some states like Texas, they didn't have anything written about like you have to have a person in the car. So you can technically like drive a Google car there, but only states like Nevada, Florida, and California have actually written legislation to allow testing of driverless cars. However, they have added laws that require the car to have a licensed driver behind the wheel to solve the question of liability. And I don't know how that's going to affect in the future if you actually had a car that could like go pick up your kids at the soccer game or something, because you still need to have someone responsible in case something happens. So although there is the Google car. Fully autonomous cars are not yet available to the public. There are many features with narrow functionalities now available on the market. These include adaptive cruise control, which monitors the distance to adjacent vehicles in the same lane and adjusting the speed with the flow of traffic. Lane assist, which monitors the vehicle's position in the lane and warns the driver when the vehicle is leaving the lane. And park assist, which assists the driver in parallel parking. And while a whole bunch of other companies like Toyota have their own version of the driverless car, Google's is kind of the most popular, and the one we saw in the video has about $150,000 worth of equipment in addition to the price of the car, as well as the $70,000 LiDAR system. So it's pricey, but hopefully they would be able to bring the price down for like consumer versions. So it's very possible. And I had another video I wanted to show you. Anybody have any questions?
How well?
Jonathan?
Yeah. How well does it deal with like that? You know, the weather, like pouring rain out or something.
They've been testing it in a lot of different environments, uncharted like back of the wood type of areas, as well as they've been doing this like 1,000-mile challenge where they drive from like San Francisco to Los Angeles, and they take like weird routes with lots of mountains and different like elevations to try to like, you know, see if the car can do lots of turns and not have any issues with that, and it's been performing well. I don't know about the weather aspect though, but I assume that they've tried that as well.
I remember a few years back there was a competition sponsored by the Defense Department, military prize.
Yeah.
This. But it doesn't seem like there's that sort of thing going on over here. Are companies really spinning consumer demand for this? Or how can they shell out how much money to do this?
Well, Google actually won, I think it was the DARPA, or they won like $2 million to continue this research a couple years ago. And Google, while they might take this, they might try to commercialize it, they are also using it in general just to like increase like the data that they're collecting. They're using it for like, you know, street view and stuff like that as well. So just increasing their like map capabilities, and they might be able to, if they're leading this, they might be able to like sell it to Toyota and have them use their system for their cars in the future. But the biggest obstacle right now is to have all the states be able to legalize the driverless car. So legislation is sort of the biggest obstacle right now.
I have no idea why that's not playing on.
Oh yeah, I would say, yeah.
I'll go one step further and predict that. You can keep it playing.
Yeah.
And predict that this would be the single most disruptive technology over the next 20 years that you guys will get with. This is going to change everything.
So this is Audi's version. Again, I told you that lots of companies are working on this, as well as BMW, Mercedes.
It's possible in 25 years you won't be allowed to drive for
So this one, they actually have no person in the car, but whenever Google goes around on their in non-closed areas, they have someone in the driver's seat ready to take over, and then also a co-passenger that monitors the system as well.
The average car in this country is parked 95% of the time. That's a huge, huge inefficiency that is just waiting to be exploited by this. Thanks, Ami.
Yeah. Also, I'm not against drones anymore. Because there's some guy that's going to use drones to deliver pizzas. I'm all for that. It'll just go to wherever your GPS is. Okay, let's talk a little bit about animation. So right now, we've just been using very simple static aspects of processing. What I'd like to do now is introduce you to a couple of there are a few built-in functions, sort of like, you know how C++, every program has a main, and main, you didn't really have to declare it anywhere. It was just sort of built in and automatically recognized. Processing has a few functions like that to accomplish various tasks. The first is something called setup. And what goes on in setup is variable initialization, for example, and canvas size, and anything else that only needs to happen once. And then the other one that we'll talk about today, there are others that I'm not going to talk about today, but the other one is draw. And everybody in here knows the basics of how animation works. Animation is a sequence of still frames that are played to you in succession, in rapid succession, so fast that your brain sort of ties them together and you have the illusion of motion. That's what draw does. Draw will generate frames at, I don't know, frame rate, number of frames per second. And it redraws the canvas. Redraws So it's no different than what you would see at a movie theater or any kind of video. You're not seeing real motion when you see a video. You're seeing a rapid succession of still frames. This is something that a computer is really good at, right? It happens really fast, and it's really sort of repetitive and boring, right? Because the difference between one frame and the next is very tiny. And it's really boring for an animator to sit down and do these things by hand. That's how they used to do it back in the day. And now most animation now is done using computers. There's very little hand-drawn animation out there anymore. Even South Park, as crappy as that animation looks, is largely automated. Let's see how one of our static algorithms would look in this context. So variables that need to be accessed by more than one built-in function, e.g. setup and draw, should be declared globally. Outside of any function. So for example, maybe I have a really interesting color that I like. So I'll declare a color variable, call it C, and I'll let it be color, and let's just say it's yellow. In fact, maybe I'll call it yellow. And I like yellow so much that I want to make it the background of my sketch. This ought to work. Let's just see if it... Oops, and I need to make a canvas size rather than the default size. So let me save this guy as April 17th, 2013 animation. You'll notice my naming convention changed. April _17 _ 2013 instead of my usual, which is 2013-04-17. For whatever reason, processing doesn't like dashes, and it also doesn't like file names that start with numbers. So I was forced to adapt. It's terrible. Okay, so I can have this this color out here. Yellow, say, or I can maybe even have a couple of colors. Color black, say. I could do that with 3, or I could do it with 1. Either way. And let's go down here and do fill black. And let's do ellipse 300, 200, 100, 100. So this should be a circle. And let's see what that looks like. So there's a yellow background, and notice I used the variable yellow to set the background instead of specifically saying what those numbers would be. And the fill is black, and again I used the variable black. Now what's going on here is this canvas is being redrawn over and over and over again, really as fast as the computer can go. Not very interesting at the moment because it doesn't change at all. We could tweak this a little bit. We could get a variable out here, say int I equals 0, and we could do something like plus I, and then we could do, oh, I don't want it there though. Let's do it here. And we could do I plus plus. So now you're really going to see what's going on with this draw command. I have this global variable I, which I initially set to 0. Actually, I should set it to 0. All of these guys should be set inside setup, to be honest, if I'm following the sort of agreed upon. So let me tweak this a little bit. This, as you already know, it's not necessary that I do this. It's just good practice. So I'll declare these guys up here, these colors, but I won't actually give them values until I do setup. Bless you. And it's the same thing with the integer I. I'll declare it up here, but I won't give it a value until setup. And why do we do that? It's again, remember that half of programming is psychology and getting it and developing good habits. And the habits here are that you should initialize these variables in the setup part of a processing sketch and declare them either as local variables or as global variables. So these guys are global variables. And then down here we are initializing. So in the setup I set I equal to 0. In draw I set fill to black. I draw this ellipse, and what's interesting about this is the y-coordinate of the ellipse depends on this variable I, which is going to get incremented every time draw runs. So what you're going to see is the black circle should drop down off the bottom of the screen. Okay, what's going on? Why did it look like that? Yeah, and it didn't erase what happened before. By default, it doesn't erase what happened before. What if I want it to erase? What if I want this perceived motion? Then I actually have to call background again.
So it doesn't erase, it just covers it.
It just sort of throws it on there, you know, and whatever's there is there, and it's a big mess. So if you want to erase what happened previously, you literally have to repaint the background. Or before each draw, I guess is a better way to put it. So let's see what that looks like. And it goes off the bottom. The circle's still there. It's just off of the visible canvas. You could do something more epileptic, I suppose, and maybe put like random 200 and just not use the I. And notice the variability is only in the y direction, and it's within a limited range, 200 pixels. So the biggest y it could be, or the lowest down it could be, would be 400, and the highest up it could be is 200.
How do you slow down the frame rate?
So actually, no, we don't have to resort to such crude measures. We can set the frame rate. This is frames per second, so we could set it to 10, which is about half of what a film or a video would do, which is about 24 frames per second. So with 10, we would have a pretty visible jump at each stage. So that's much slower than it was before. You could go further and really, you know, knock it down to 5, say. And you could throw a little bit of randomness in the X direction. And it's kind of trapped down there in that lower right quadrant. Questions about that?
So 300 is the starting point.
Say again?
300 is the starting point of 500.
Yeah, so the center of this guy is at 300, 200. And then the maximum x coordinate would be 500, and the maximum y coordinate would be 400. One last thing before you go. I promise to talk more about this next time. I can replace this with a couple of reserved variables. Oh, and I should crank up the frame rate. It's not looking very good. In fact, I'll just turn off the frame rate. So these built-in variables, mouse x and mouse y, always have the coordinates of the mouse pointer. And by feeding those coordinates into the ellipse command, I'm centering the circle at the location of the mouse. This is the very beginning of user interactivity. Yes?
So can you go off on the left side, drag it all the way around outside the canvas on the right side?
It'll just pop.
Just pop.
See?
Fall.
yeah, it just kind of sits there and it's waiting for coordinates. They're kind of stuck at the last inbounds coordinates. And then over here, as soon as it gets in here, it's got, hey, fresh coordinates. And yeah. Sebastian, last question.
Yeah, I was wondering if they use processing to make those ads on the internet that you can drag your mouse.
There are so many different ways of doing that. Processing is one, and probably not the one that they use. But yeah.